be presenting about our case study, which is application of cryptography. Cryptography is being a plain text or message in disguise into a chain of secret and secure coded text. A cipher is an algorithm for performing encryption or decryption, which is a series of well-defined steps that can be followed as a procedure. Here we will show an example of the application of cryptography in mathematical methods used these days.
I will explain the purpose of this project. The purpose of this report is to study on how ALGEBRA implement the use of linear algebra and matrices on its algorithm. Demonstrate by using a video on how an information or a data which is disguised or encrypted, which is also called as a ciphertext, that does not reveal the original input, can be reverse transformed by a designated recipient so that the original plaintext can be recovered. Furthermore, the video will be visual representative on how the encryption and decryption works so that the readers and viewers can understand it easily. Next, the methodology of this project. The project use a qualitative method which is based on Lester S. Hill Cryptography in Algebraic Alphabet, the American Mathematical Monthly, Volume 36, Number 6, June until July 1929, on page 306 until 312. This study was conducted by researching on the internet, referring books and websites, which will be on the reference page. The content of Lester Hill work was more to mathematical approach, so further analyze on how the mathematicals behind was needed to ensure that the value will be accurate and sufficient based on research materials. In addition, the materials were analyzed using thematic and content analysis. This included coding all the data, defining keywords, as well as finding the intent and messages inside the materials. Coding the data here means gathering information on the basis of the content. For example, the file is using a mathematical approach, hence the point should be understanding the concept and logic behind the algorithm. Other than that, the ALGEBRA included matrix multiplication, determinants of matrices, and matrix adjunction for this algorithm, which are topics that students learn in linear algebra. In short, this technique is the best strategy for the team since it is partially adequate to collect information and complete the study. Thank you.
In this section, we will apply the method to encrypt plain text messages using 2x2 encoding matrix. Using the encoding matrix A1213, encode the message "thank you." The solution: first, we divide message into group of 2 letters. The word is "thank you", so the first group is TH, second AN, third K space, fourth YO, and lastly U space. Note that since U is a single letter left from the word "thank you", it is necessary to add a space to complete the last group of 2 letters. Then we assign the number for their corresponding letters from the table. Convert each pad into 2x1 matrices: TH 28, AN 114, K space 1127, YO 2515, U space 2127. In this stage, our message expressed as 2x1 matrices as below: 28, 114, 1127, 2515, 2127. Now, to encode the message, we multiply each 2x1 matrices of our message by the encoding matrix A. We know that encoding matrix A is 1 to 1 3. So we use matrix A multiply with each 2 by 1 matrices. From the multiplication of matrices above gives us the desired encoded message: 36 44, 29 43, 65 92, 55 70, 75 102. The encoded message transmits in the following linear form: 36 44, 29 43, 65 92, 55 70, 75 102. The next section, we will apply the method to decrypt the previous encoded message using 2 by 2 decoding matrix. These are the 2 by 1 matrices of encoded message. The solution: first, we need to find the inverse of encoding matrix A, also known as decoding matrix A. We know that encoding matrix A that we used earlier is 1 to 1 3. So to get decoding matrix A, we need to exchange the place of number 1 and number 3. Then we add negative to number 2 and number 1. So the decoding matrix A is 3, negative 2, negative 1, 1. Now, to decode the message, we multiply each of the 2 by 1 matrices by decoding matrix A. So, we use decoding matrix A multiply with all 2 by 1 matrices. From the multiplication of matrices above gives the desired decoded message: 28 1 14, 11 27, 25 15, 21 27. Finally, by associating the numbers with their corresponding letters for each pair, we obtain TH AN K space YO U space. The message written in linear form reads as "Thank you."
Okay, now suppose we wanted to use a 3 by 3 matrix to encode a message. Then instead of dividing the letters into groups of 2, we will divide them into groups of 3. Okay, using the matrix B, encode the message "Congratulations." Okay, for the solution, we first divide the letters of the message into groups of 3. As you can see here, I have divided into 3, which is CON, GRA, TUL, and so on. Okay, note that since the letter exclamation mark was left over on the end, we added 2 spaces to make it into a triplet. Now we assign the numbers their corresponding letters from the table and convert each triplet of numbers into 3 by 1 matrices, and we will get CON equals to 3, 15 and 14, GRA equals to 7, 18 and 1, and TUL equals to 20, 21 and 12, and so on. Okay, so far we have these numbers that represents the word congratulations. Next step is we multiply on the left each metric of our message by the matrix of B. For example, this matrix of B is multiplied by the numbers that represent CONs, and then we will get these answers. By multiplying each of the matrices in 1 by the matrix of B, we get desired coded message as follows. If we need to decode this message, we simply multiply the coded message by the inverse of B and associate the numbers with the corresponding letters of the alphabet. Okay, now I'm going to explain how to decode a message. Since this message was encoded by multiplying by the matrix B, we first must determine the inverse of B. Okay, the first step is we must find the determinant of matrix B. To get the determinant of this matrix, I'm going to expand along the first row. So it's like 1 times 1, 5, 1, negative 4 minus by 3 times 2, 5, 2, negative 4, and then we will going to add 2 times 2, 1 and 2, 1, and then we calculate all these numbers and then we will get these answers. Okay, then the second step is we are going to create a matrix of minors. After that, we are going to apply matrix of cofactors, which is by adding the positive and negative to each of these matrices here. Okay, after we calculate each of these matrix here, we will get these answers. Okay, now for the third step is we are going to transpose the matrix. This makes the columns of the new matrix the rows of the original. Okay, for example here, the first column here, we are going to convert it into the first row here, and the second column here, we are going to convert it into the second rows here, and the third column here, we are going to convert it into the third rows here. Okay, the next we are going to inverse the matrix by dividing the determinant of the original matrix. Okay, this 1 over 45, these are the numbers of the determinants that we have calculated earlier times by the transpose matrix that we have done. So we will get the inverse of B. To decode the message, we multiply each matrix on the left by the inverse of B. For example, these are the inverse of B times by the first column of the encoded message, and then we will get this answer. Okay, by multiplying each of the matrices in 2 by the inverse matrix of B gives the following results. Finally, by associating the numbers with their corresponding letters, we obtain these letters that represents congratulations.
Conclusion: the art and science of concealing the messages to introduce secrecy in information security is recognized as cryptography. The secret code is a cipher which encrypts messages so that the content will be shown as a code, while decryption works the other way around by changing the code into plain text. Nowadays, mathematical methods makes encryption and decryption much more effective and concealed in keeping data private. That's all from us. Thank you.